All right, trig students, so what we're going to be doing is jumping into a new chapter, and with that new chapter what we have is a new idea, and what we're going to be doing is, at least in the first part of this chapter, is solving what are called oblique triangles. All right, so let's go ahead and do some groundwork first, share some ideas. Again, the book has a lot of nice, neat highlighted boxes and all that. I know we're towards the end. I know you guys are getting tired, so what I'm trying to do is just trying to even summarize the book's summaries and just give you what's important and what we're going to be using. So the first thing that we have to do is talk a little bit about what it means to be oblique. All right. Essentially, the definition of an oblique triangle is anything that's not a right triangle. Right. And don't confuse this what went to be obtuse. Right. Obtuse triangles were basically one of the angles is basically between 90 degrees and 180. All right, that's what it meant to be obtuse, but don't confuse that with oblique. All right, yes, most obtuse triangles are oblique, right? But there are some there are some non-right triangles that are not obtuse, right? Because we can have some angles that aren't quite over 90 but still add up to 180. So oblique just basically means we're dealing with any situation that's not a right triangle. All right, it could be an obtuse as well or not obtuse. Another fact that we're commonly have used that's going to play a huge role in our work in the first three sections, at least, of section 7 or chapter 7, is the fact that the angles, right? So if this is angle A and this is angle B and this is angle C, right? We know that if we summed all those angles, it's going to equal 180. So that's another factual truth about triangles, whether they're oblique, whether they're right, whatever the case might be. And we've used that from time to time, but it's going to play a huge role in our work when we are working with oblique triangles. All right? And then solving, what it means to solve an oblique triangle, like we're going to be doing in 7.1, it's asking us to basically find all the sides and find all the angle measures. That's pretty much the same thing that it meant when we were solving right triangles earlier in our semester. Basically, we have to find all the sides and all the angles. What was nice about a right triangle is we knew that one of the angles was equal to 90. So one of the angles is already known. What's tougher about an oblique situation is A is unknown, C is unknown, B is unknown, and then what we usually do in terms of terminology is the side opposite of A, we call it little a, the side opposite of B we call little b, and the side opposite of the angle C we call little c. So there's some terminology. I'm getting to the lingo there, but that's what we normally do with an oblique triangle. So the uppercase letters designate the angles that are involved, right? And the lowercase angles designate the sides that are involved, right? And usually the lowercase is opposite its angle, right? So the side B is opposite angle B. The side A is opposite side angle A, and the side C is opposite the side C there. Another part of lingo when it comes to talking about oblique triangles is we talk about things like SSA or SAS, all right, or AAS, all right, and you could even have an ASS, right? So we'll try not to make an ass of ourselves, all right? Little joke there, all right? What in the world do we mean by this? Well, the side, right, the S's represent sides, and the A represents an angle. So what this lingo is basically telling us, when I have a side-side angle, that's basically telling us that I have an oblique triangle situation where a side is known, and then maybe that angle A is known, right? And so that's basically telling us what's known. So I have a side, and then I have an angle. Usually this angle is when we write it this way, this angle is not including one of the sides. It's definitely not going to be this angle here, because if it was this one, right, that would be a SAS, right? So that is a situation where I know a side, I know an angle, and I know a side. So this is just lingo for telling us what is given. So either two of my sides is given and then an angle that's not included between them, or in this case, an SAS triangle or an oblique triangle is where a side's known, and then the angle between those two sides is known. So we call that SAS. An AAS, well, this is a situation where, again, let me draw my oblique triangle, where an angle is known, right? But then one of my sides is known, right? And so it could be this situation, it could be this situation, right? But it's not definitely, let me kind of get to, if we had, if this was known, that would be an ASA, right? Because in that situation, an angle is known, and the side between them is known. So there's some of the lingo. And of course, you know, what's an AS, right? Well, that would be something like the angle is known, the side is known, and the side is known. All right, so that's kind of a flip side, right, of that guy. So there's some lingo that's happening here. When you see combinations of S's and A's, there's only going to be three of them because there's only three angles and three sides. But what it's telling you is what's known, and so that's basically what's happening with that crazy lingo and notation. So it's what's known, and of course this brings us up here what it means to solve. We got to find the other. So I'm either given two sides and an angle, so I got to find the other two angles and the other remaining side, right? Two sides and an angle. I got to find out what that angle is, and what that side is, right? Maybe I'm given two angles, so I got to find out what that angle is, and then what's that side, and what's that side, right? Or maybe I'm given an angle, and a side, so I need to know, again, what's that side, and what's that angle, all right? So there's basically, again, some lingo about what's given. That way we know what kind of picture we can draw. And then it turns out that to solve an oblique triangle, we need to have the following data in one of the following cases. Case one is that one of the sides is known and two of the angles are known. So we're talking about SAA or ASA, right? This is usually the nice case of the law of sines. And this is the case that's going to be predominantly in section 7.1. Case two of the sides are known, one of the angles is known, but this angle is not included between the two sides. All right, so this is what we call an SSA. So something, something like this right here, right? So this is in reverse. This is an ASS. Some people would call that an SSA as well, right? I just wanted to play around with the verbiage. So in this case, right, two of the sides are known, and the angle is not included in the side. It's off to the, maybe it's here or maybe it's up there. It contains one of the sides, but not both. So that's what we're basically talking about there. This is what we call the ambiguous. Let me hopefully I can spell it right. The ambiguous law of sines. So we're going to see these more in 7.2, all right, when we consider that. This case is not unique at times. It's a little bit crazy, so it has its own section all dedicated to itself. Case 3, two sides are known and the angle between them, so an SAS. So that would definitely be something like this. A side is known, a side's known, and the angle between them is known, all right? In this case, what we're going to be doing is using the law of cosines. So we'll take a look at these in 7.3, and then the situation where all the sides are known. So SSS is known and the angles are all missing. And again, this will be a law of cosine situation, 7.3. All right, and then last but not least, it turns out that if a triangle where all the angles are known, so I have an A, and an A, right? It turns out that these can be solved, but they're not going to be unique, all right? Because of the idea of similar triangles, right? So these two triangles are similar, right? Because the angles are the same, but this side, and this side, this can be a bigger S and a bigger S and a bigger S. So it's not going to be unique. We can even have a smaller one, right? So real tiny s, real tiny s, a. So triple A's are really hard to solve because you can do it, but then we don't really know what triangle we're talking about. Are you talking about this little tiny one? Are you talking about this real big, this middle one? Are you talking about this real big one, or anything in between? So this is a very, very hard case to solve. It's doable, but it's not unique. There's multiple answers because of the idea of similar triangles. These cases, though, right, we do in fact get some nice unique situations. Maybe there's a couple of them, right, but there's definitely going to be some unique answers to it. All right, so that's kind of where we're heading. Some of the lingo involved, some of the casework that is involved, and right now what we'll do is let's go ahead and talk about case one, right? What is a law of sines, and how does it help us solve side angle angle or angle side angle situations? And that will be coming in some videos soon.